All right. Good morning, everybody. I hope you're having a great day today. Welcome back to Comp 2452, Software Development 2. So right now, we've got lots and lots of stuff here. Over the weekend, we've amassed 4.5 quadrillion cookies. I think we could probably buy a couple of upgrades, but I do want to save a quadrillion cookies so I can buy this for the afternoon class. So I just want to make sure I'm not buying too much here. That's too much. I better stop there. I don't want to buy any more than is strictly necessary. One thing that we haven't done yet is we haven't changed the name of our bakery. So what should we name our bakery? Because we'll get an achievement by changing the name of our bakery to something else.
With the dash.
With the dash, okay. We've unlocked an achievement. What's in a name? Okay, yeah, thank you. That was not very imaginative, but thank you for actually volunteering to say something. And I mean, we can buy a couple more upgrades here. We're down to prisms here, so this is converts light itself into cookies. Oh no. Oh no. Now I really hope that we're going to have a quadrillion cookies by this afternoon, but I'm not sure that it's going to happen. We're just going to have to sit here and click the cookie all class today. No, I ruined it for the other class. You better be happy about that. Okay, so welcome back to Comp 2452. Last week, where we ended was we were kind of taking this idea of our class diagram. We took this idea of our domain model, and we're starting to make changes to that. Not like adding new classes, but more trying to make changes to it such that we can start to think about persistence and start to think about moving from objects into this relational model. So building up tables that represent the same kind of core ideas that we have in the classes that we've got. At the very end of last class, where we got was really like, I'm going to start writing some SQL code to start creating these tables. But to be clear, the goal for last week's class at the end was very much about, I want you to be aware of a hazy idea that there exists a programming language called SQL, and there are statements like create table. That was the goal of last week. And like in the hasty 10 minutes of the end of class of let's type in create table, I hope that we've accomplished that. I'd like to revisit that today. I want to spend some time thinking about not just this idea of create table statements, but I want to have a mental visual model of what tables look like. That helps me imagine what's going on when tables are being created, when I'm adding information to tables, how tables are related to each other. I like to have a visualization in my head of what that structure looks like. Once I've got that idea in my head, then we will go back to, let's start making these tables in our database, and we're going to start working with our database in terms of adding data to it. I want to put data into it. I want to be able to ask about the data that's in it, so I want to write queries. I want to ask for it to give information back to me, and I want to make changes to the data that's in the database. So I want to change existing data, and I want to remove data from the database as part of the operations that we're going to do today. The very end of what I'm hoping for us to get to is starting to think about what happens when we have these aggregate and composite relationships. And similar to what we thought about in Comp 2450, how do those kinds of relationships inform the structure of the tables that we're going to be making to represent the same data in our relational database? So by the end of today's lecture, I want you to be able to I want you to be able to model these relationships between data model objects in a database. So I want you to be able to continue to think about these ideas of uniqueness constraints, this idea of explicitly saying whether or not something can be null, the idea of adding cardinality to our database, or to our domain model, our class diagram. So thinking about which end has one versus which one has many versus one-to-one sort of relationship. And then what I want to do is spend some time actually writing some SQL here. So visualizing the idea of what these tables look like, at least from a mental model perspective, how they're related to each other, and then actually starting to write the SQL code to do this. Next week, so after our term test, what we'll start beginning to think about, is we're writing SQL in this REPL thing. How do I actually start taking that and putting it into TypeScript code? So how do I start interacting with the database from the projects that we're actually working on? But for this week, the focus is really just about how do I interact with SQL? I don't want to think about integrating these things together. I just want to do this all by itself, thinking about SQL and relational databases. So to remind you where we were last week, the distinction between our domain model, what we've been doing in Comp 2450 and what we're doing now, is that our domain model here has behaviors. This is really the major difference between our domain model and this idea of a data model. Data models are just inert. It's just data that's sitting there in a pile. It's structured, but it's not doing anything. It doesn't have actions on itself. It doesn't make changes to itself. It just sits there in this structured pile, and it just kind of doesn't really do anything until we ask questions about it. And the database is going to give us the data back based on the kinds of questions that we're asking. I want to start with a quiz. I'll hold this up for about 5 seconds, and then I'll switch over to Mentimeter. Okay, I'm going to switch over. And I got a few questions for you here, really about some of the stuff that we did last week and then some of the stuff that we did in Comp 2450. We'll hold for 1 more second, and then I'll start the quiz. All right. Okay, good. So the 2 main things that we did to this was adding constraints and adding cardinality. Well, while the idea of a data model does not have behaviors attached to it, we didn't remove that idea. We're trying to take these 2 concepts and smush them into one diagram. So we're not removing anything from it. We're really just adding stuff to it. And the 2 ideas that we really added to this, at least in the context of our class diagram from last week, was I added these constraints and we added this idea of cardinality to our diagram. Here's our next question. Okay, all right. So, yes, no 2 instances can share the same value for that instance. So when we're adding this uniqueness constraint, this was that tilde symbol that we're just like convention 2452 convention adopting. I'm going to say that this tilde is going to represent the idea of uniqueness on a property. And the idea within uniqueness of a property is that in our OO model, we're going to be able to make many instances of this object. But what we're trying to ultimately say is that no matter how many instances that we create here, no 2 of them are going to be able to have the same value. So if we're thinking about things like strings, what I'm trying to say is that if I called all instances of this thing that I have in the system right now, if I called dot equals on all of those and did an all against all comparison, none of them will be allowed to have the same value for that specific property. This is slightly distinct here. When I say none of the instance variables here, this means to me across all instance variables, this is me being a bit of a pedant, I guess, about the distinction between an instance variable versus all instance variables within a class. For that one, what I'm thinking about is if I make an instance of a class, none of the values of the variables can have the same value. This may be technically true, I guess, in some cases, but it's not quite what I'm thinking about. And then uniqueness here doesn't really say anything about being able to make instances of a class. We've thought about this before, and you've thought about this, I think, going all the way back to Comp 1020 in terms of design patterns and singleton. Singleton is a way that you can force only one instance of a class to be created, but it's not in the context of this. So for uniqueness, for us, the key idea is that we're going to be able to make many instances of these objects, but none of them are going to be able to share the same value for that specific instance variable. Is that okay with everybody? Any questions? Okay, awesome. John Braco's here today. And he's only doing okay. He's only doing okay. Okay, we got a couple more questions. Whoops. Okay. All right. So this point here, it will be easier in the view to get related information. I'm going to give a little bit of spiritual credit to that to say, sure, yeah, it will be easier to get that information. If I'm looking at a Pokemon, I can have a link or a button or a label that says it's owned by this trainer. Yeah, absolutely. That's possible to do that now. In the context of, I want to take our domain model class diagram and start to do things like modeling the relationships so that we have this idea of a data model, and I want to put this into a persistence mechanism that is a relational database. This one is the key idea here. When we have these tables in a relational database, we don't have an infinite number of columns. If I have a collection of something, I'm not going to be able to just have columns and columns and columns that represent each of the things that are in that collection. I'm not going to be able to do that. I'm gonna mention this later, but even in Excel or LibreOffice Calc or whatever it is that you're using as a spreadsheet, Google Docs, the number of columns is limited to 16,384. I believe that's what the column limit is. 16K columns. Once we pick the columns for our tables, we're actually going to be kind of stuck with those columns. We can add new ones later, but we're not going to add them dynamically. We're not going to be making new columns to represent all of the members of a team on our trainer. So the idea here is that I want to take the relationship that we've got and I want to invert that. I want to have that idea of a trainer has a collection of Pokemon on its team, but the way I want to model that in my database is that a Pokemon is owned by a specific trainer, and it's always only ever going to be one specific trainer that will own that Pokemon. I'm going to give some spiritual credit to this option. Yeah, I guess philosophically Pokemon really should know who owns them, but you know, that's a little bit outside the scope of this course. Here's another question, and then we'll have one more after this. Okay, good. Yeah. So the key thing that we were thinking about with composition and aggregation in the form of using JSON, composition and aggregation being about the ownership between instances of these different classes, that led us to, we're going to embed entire instances of this class inside of this other class in the JSON file that we're constructing here. This is a big shakeup here, I think. John Brayko is like gaining some ground. Okay, good job, John. Here's the last question, and this one is going to be, let's extend on the idea that we have so far. It's about the same idea, composition and aggregation, but how might it inform persistence for us in this class? Okay, all right, okay. To be fair to all of you, I am asking you this question before we've even talked about it, but that's fine, that's fine. This is going to be a real shakeup on the leaderboard because of whoever those two people are going to pop up quite high. We will talk about this idea, but ultimately, the place where we're going to see this is deciding when to delete these reference rows. The word that I'm going to use when we get to this point is cascade. This is the word that I'm going to use to think about this idea of instance ownership. It's going to be about deciding when to delete these referenced rows. Okay, all right. Whoa. That was not as big as a shakeup as I expected. All right, so congratulations to whoever Bell is, and John, I'm glad you could participate in this Mentimeter with us. I will make a point of trying to make sure I remember to put this up on the course webpage after today's lecture. Thank you for the person that reminded me to do that. I do mean to be doing that. I just kind of fell off my plate. So I'll try to make sure that this happens after class today. Okay, so quick reminder. What we did last time was we added some extra information to our class diagrams. So we added this idea of cardinality, and there's several different kinds of cardinality here. So one-to-one versus one-to-many versus many-to-many. And this is kind of about the structure of the classes that we've got. One-to-one is I've got two different classes, and they each have individual references to each other. One-to-many is I have a class that has a collection of something else. And many-to-many is I have two classes that have collections of each other. So one-to-one, many-to-many here, a good example of this to me is something like students in courses. A course has many students, a student has many courses. They may not overlap with each other, but they both have collections on either side. We also added this idea of back references. I want to make these relationships where I can bidirectional. And the goal for this is going to be that we really do not have an infinite number of columns in the tables that we're going to be working with. So I really want to be able to have something that's going to be on the one side of this one-to-many as opposed to just having the array collection on the other side. We also added some extra information here, like I explicitly want to state now, can this value be null? Is it okay for this not to have a value? And if it's okay for it not to have a value, I want to say that. If I don't say that it's not okay for this, if I don't say that it's okay for this to not have a value, then I'm assuming that it is not nullable. So this is something that must have a value in the table. And then this idea of uniqueness. So I want to make sure that despite me making as many instances as I have, when we get to the database itself, we're going to force that we can only ever have one value, one unique value per each thing in here. Yeah.
Okay, so when we have a many-to-many relationship, would that be problematic to kind of embed in our database?
We'll talk about this later. There are some places where we're going to have to make changes to the structure of our tables to kind of deal with stuff like this. This is one place where we're going to have to do that. And another place we're going to have to do that is when we're starting to think about inheritance. But we'll do that later. We'll do that later. The short answer to your question is we'll have to add another table that represents relationships. So it's no longer just representing class A and class B. It's also representing the idea of a relationship between A and B as a separate thing. Yeah. The conventions that we had for cardinality was that we were using these symbols 1, plus, and star. And when we were adding this, we were kind of adding it on, I'm looking from this class at the other one. I have exactly one of these things. I have many of these things. We use the question mark to say that this is going to be able to be null or undefined, and a value that is unique has this tilde as a prefix. So here was the structure of our class diagram by the end of the class last week. And the structure here is that we've got things like trainers, we've got Pokemon, and we've got that new idea of a Pokemart. Pokemon have hit points and nicknames. The nickname on a Pokemon must be unique across all instances. We have this idea of trainers having a team of Pokemon. We added that back reference. We added a trainer to the Pokemon type. We also added the cardinality here. So when I look from trainer to Pokemon here, it's a composite relationship up there, and I can have 0 or more of them. So a trainer may have no Pokemon on their team, but they might have many Pokemon on their team. When I'm looking back from Pokemon at trainer now, it's an aggregate relationship. I have an instance of trainer here. I'm looking back at that. I don't own the trainer that I'm attached to, but I do have a reference to them, and I've got exactly one reference to those. This is something that I have not marked as nullable. I don't have the question mark there. So for me to be in the database, when we're thinking about the databases, I must have a trainer. I'm not allowed to have Pokemon in this database that do not have trainers attached to them. The other relationship that we've got here is this relationship between trainer and Pokemart. Trainers can have a favorite Pokemart that they like to shop at. And what we've got here is that we've got exactly one favorite, but that one favorite Pokemart can be nullable. So I've got that question mark that I've added there. And that's really just to say that I don't have to have a favorite Pokemart. It's not a requirement. I can if I want to, but I don't have to have this thing. We added a back reference to this, but the form of the back reference here was, it was a collection that we were adding as a back reference. So when I'm looking back to the trainer here from the Pokemart, the asterisk there is below the aggregate, but both of these are aggregated of each other. They're not kind of like owning each other as instances in terms of the ownership structure that we've got here. The name of the Pokemart, though, must be unique, and the nickname for the trainer or the name for the trainer must be unique. So across all instances of each of these, they must be unique. Yeah.
So in our domain, we don't have nickname. Then here we do have a nickname. So we need to change it and maybe ask the user for a nickname later?
So for this specifically here and this specifically here, we didn't originally have nicknames. If we were to take this structure and modify our implementation of MVC to adapt to these changes, then yeah, we would then start having to ask, what's the nickname of this Pokemon? What's the nickname for the trainer that you want? We have to have that information because we don't want to have duplicates. We don't want these to be duplicated. We want them to be unique across those instances. So we have to have that information to be able to do it. I guess to that point, we also haven't marked these as nullable. They're unique and they're not allowed to be null. I haven't put that question mark on them. Are there any other questions about the structure that we got? Yeah.
For arrays like the team of Pokemon or the favorites, if we want, I feel like the Pokemon could have no people who favorite it.
Yeah.
If it is allowed to be empty, can we put an exclamation mark, or sorry, a question mark, or would that be saying the array is null?
So that's a good question. The question is, if this is allowed to be empty, can we put a question mark here? I'm going to say that I wouldn't put a question mark here for two reasons. One is that I wouldn't want to say in TypeScript that this is allowed to be null. I don't ever want to have a null property for that array. I always want it to be at least an empty array. But the other thing is that, at least in the context of data modeling, I actually wouldn't put anything in the Pokemart about the array of trainers that are favorited by. The purpose of this, adding that array, was really just to kind of make the bidirectional relationship exist. I could pretty reasonably just omit this entirely and not have favorited by here at all, but just to be consistent with the rules that we've set up for a convention, I want to have that bidirectional relationship. Yeah.
For these nicknames, is this something we cares about? Is this just for the system?
For us, this is something that we would ask the user to provide to us as inputs, yes. There are circumstances where it's not possible for us to have a unique thing for all instances of these classes where it's kind of outside the scope of something that the person sitting in front of the machine will need to know about, and we'll have to come up with some artificial value that represents a unique value for that thing. For now, at least, we're going to omit that idea. When we get to it, this is going to be of the form of, I want to have like some unique numeric identifier that my user doesn't really know or care about, but it uniquely identifies that thing when I have no other way to uniquely identify that thing. For now, this is good enough, and this is something that they can care about. Yeah. Any other questions? I'm realizing today that it is, we're nearly at week 6 of this course. And that means that the week after next is a reading week break. Yeah. And I don't know about all of you, but I am delighted by that. Yes. I don't know about all of you, but I'm delighted by that, partly because I don't know about all of you, but I'm really feeling the Januaries now that it's February. Yeah. And like Walter at home is also starting to feel the Januaries. But like for Walter, he's not, like I don't let him free roam. I don't let him out in the neighborhood. I don't let him wander around. And as I've demonstrated to you, the face that he puts on when I open the door for him right now is to just like shrivel back into himself. But he also has the kitty crazies a lot, and he's just running around the house. And I don't know if I've ever mentioned this to you, but Walter has this like, he has a little belly that we call his pocket that he runs around, and it just hangs beneath him and it wobbles back and forth as he runs. And with the kitty crazies, it just really wobbles back and forth real fast. And I worry a little bit that he's going to take off one day and go airborne. But the worst part is that when Walter gets the kitty crazies like this, he also gets the kitty crazy eyes. And I don't know, like if you have never owned a cat before, you may not know what these eyes look like, but they're big black circles. They are very big black circles. And for me, that means often I'm going to be bitten soon if I'm not careful. And I need to like leave the room. Otherwise, he's going to bite me. And so I'm looking forward to being able to get out. And I think he's also looking forward to being able to get out. And so hopefully, you know, in the next 6 months, we'll be able to do that. But it is Winnipeg, so we'll have to wait until at least March for that to happen. Anyway, let's think about SQL. We've got this updated class diagram. We've added some extra information to it, in some cases for kind of weird sounding reasons. Like, I want to go back to this point. I do agree with the people that selected. It's now easier for us to put more things and access information in the view because we've got this back reference. Again, I want to give you spiritual credit. I think that that is true. That is a true statement. But the goal of that was not about making our lives easier in the MVC architecture. The goal of that was really about migrating towards relational databases and tables. So how do we go from these classes now to actually thinking about tables? And we're going to use SQL to do that, but I kind of want to be able to think about what this idea of a table is first. When I'm starting to think about tables, I like to have a mental image. My mental image is really just two-dimensional tables, but I want to share that mental image with you so you have something to think about when we're starting to do things like create table statements and asking questions about the data that we have in our database. So you can imagine what's kind of going on internally here. I want to visualize these structures, and as we're visualizing these structures, I want to consider some ideas. The first is that tables in a database, when we make these tables, do not have infinite columns. They have as many columns as we want to make, but we have to make that decision when we're creating the table. Tables don't get modified by us adding information to the database. This is a structure that I have to decide on, and I kind of have to fix on what these values are going to be for columns. Databases don't have infinite columns, and I pulled this up because I mentioned it last time. I wanted to show you this. 255, first of all, is not just a random value that I'm plucking out of the air here. This is consistent with Excel in terms of spreadsheets. But the important part that I wanted to show you here is that the total number of rows and columns on a worksheet is, you can have about 1 million rows in an Excel spreadsheet, and you can have 16,384 columns. And that's a special value now that you're doing Comp 2280, in that that's a power of 2. That's conveniently a power of 2. That is 16K. That's 16K. So that's 2 to the power of 16, I think. Is it? Yes. Yeah. Yes. Yeah. Yes. Is it? Yeah, I think so. It's 2 to the 16. It's 16K. Oh my gosh, no, it's not 2 to the 16. Not at all. It's like... two to the 14, is that right? It's 2 to the 14, yes, thank you. It's 2 to the 14, yeah, okay. So it's 2 to the 14. This is a power of 2. We don't have an infinite number of columns, but at least in Excel, when I make a spreadsheet that looks, I don't want my calculator again, I want LibreOffice Calc this time, thank you. When I make a spreadsheet here, and I can start labeling these things like nickname, and I can say things like HP, and I can say things like trainer, I can pretty easily insert columns before, and I can start adding stuff to this if I want to. SQL tables, while we can add more columns after the fact, it's less straightforward to do that. And we really don't want to be constantly adding new columns before every time we wanted to add a new member to the team of the trainer that we've got here. So our tables, once we've created them, don't have an infinite number of columns. When we're going between OO, the structure and kind of model that we've been thinking about all the way up until now, and toward relational databases and tables, there are some things that we cannot map directly between those ideas. Formally, this is called the object relational impedance mismatch. There are some ideas that we have in OO that cannot be translated into tables. So for example, I can't directly take collections and apply that to this idea of a relational model. I'll come to you in just a second. I cannot add an infinite number of columns for trainer. Instead, I need to invert the relationship that we've got so that I have a Pokemon having exactly one trainer as opposed to a trainer having arbitrarily many Pokemon. I've got to invert that relationship. Another thing that we don't have to map between OO and tables is encapsulation. I can't have private members in a table. That's just not something that is represented. There is no public, there is no private, there is no protected. There's no inheritance hierarchy in tables. I don't have a structure to represent all of those things. In polymorphism, there is no inheritance. I can't say that this table extends this other table. That's not a thing that we can do with the structure that we've got here. And so we've made some changes to try and address these issues, like collections. Encapsulation, we're just never going to touch. There is no private data in a database. There's no protected data in a database. There's all public. Everything is public all the time. And with polymorphism, we'll deal with that later. For now, we're just going to ignore it and pretend that that's not actually a problem. I'll come to you in a second. I'll come to you first. Yes. So that's a fair question. If there is no infinite number here, and Excel is a kind of a bad example, I guess, because it's really meant for the small scale data. Real relational databases, the limit that they have on rows is like arbitrarily large. It's as much as you really can fit on a disk. That's now going to be your limiting factor. Other kinds of storage tools will have also arbitrarily large limits. Columns, we could have more, I think, than 16,000 columns in a relational database. But in terms of, I want to take these classes and turn those into tables. If you have a class that has more than 16,000 properties on it, you're doing something very, very wrong. Yeah. There's lots of stuff that's outside the scope of this course. Like there's an alternative way to think about this called column stores, but we're just not going to think about that in this course. I want to fix to relational databases that we've got. So we're not going to be limited to 1 million rows in a database. It's going to be effectively as much disk space as we have. We're not going to touch anywhere near either of those limits in this class at all. But in the real world, yeah, real relational databases don't have these artificial limits. Yeah. Yeah.
So we were talking about how in our data modeling in SQL, we're not like accounting for any of the behavior between classes.
Yeah.
Like, as they stand. There are still ways to modify the data in SQL, just looking through the slides ahead of time. So
Yes.
is SQL considered Turing complete or no?
Okay, so to your point, the programming language SQL will allow us to modify the data, yes. But in the sense that OO, when we have an object and a class, the class itself has behaviors, and the behaviors modify the internal state of that object. With SQL, we're doing this from the outside. We're describing the changes that we want to make to the data, as opposed to the data having kind of something that makes changes to itself. Is SQL a Turing complete language? I mean, I believe so, but I'm not gonna commit one way or the other. I would advise you not to do large-scale programming in SQL.
No, I'm just curious.
Yeah, I believe that at least if the language itself is not Turing complete with all of the extensions that different database vendors have, it probably is Turing complete. There are also lots of features of SQL that we will not at all touch in this course. This course is not about SQL. There are conditional statements and there are loops in SQL, but we will not be doing conditional statements and loops in SQL in this course. We will do conditions, sorta, but not conditional statements in the same way that we're traditionally thinking about those things. Okay. Any other questions so far? Okay. So the other thing that we're going to think about here is how composition and aggregation are going to inform the constraints that we've got. And as I mentioned before, this is really going to be about making decisions about what happens to data that depends on other data. So when we have collections, we're going to have references between these table structures. In OO, the ownership of the collection is implied by having something be in the collection. We still need to have that relationship. We need to express it differently, that bidirectional idea. But we also now need to be able to make decisions about when we have OO and collections, when a trainer goes out of scope, all of its Pokemon also go out of scope. If I delete a trainer from the database, how do I make all of the corresponding Pokemon also be removed from the database? So composition and aggregation here are going to inform these constraints that we're adding to our model. So I'm going to pop over here. I'm going to quit this. I'm going to start this again so that it actually shows up on our screen. Here we go. And what I want to do here is I want to take that class diagram. And again, I just want a visual representation of what this structure looks like so that when we start to write these SQL statements, we can imagine internally what that structure is beginning to look like. So we have three core ideas. The three things that we have in this system are going to be the Pokemart. We've got trainers, and we've got Pokemon. Typically, when we're making these databases, we're going to have one table per class. So we're going to have a table that represents the Pokemart, we're going to have a table that represents trainers, and we're going to have a table that represents Pokemon. I'm going to start with the Pokemart table because it doesn't have any references itself to anything else. It's entirely independent of all other tables that we have in this system. Mentally, when I'm thinking of a table, I am thinking of a rectangular structure. I'm going to give this a name. This is going to have columns in it. The column for our Pokemart exists, it has exactly one column here. The column that I want to use for this is really just name. Initially, it's empty. There's nothing in this table. I don't have values in this table. It's just a table that consists of a single column, and that single column is name, and nothing else here. This is a string, and we have to do some translation between the types that we have in JavaScript and TypeScript and Java and C and C++ and other systems that we have to the types that we have in SQL. And so for us, this is going to be that varchar type. I'm going to specify that there's 255 maximum characters in this column. But we're going to fix on this idea of the Pokemart has one column and the type that it has is varchar 255. The other class that we have is trainer. And that's the next one that I want to start thinking about here. Again, it's a table. I want it to have this rectangular structure. It's going to have columns. The columns that I want to have on my trainer class are going to be name. I'm going to say that this is varchar 255. So this is a string. And the other column that I want to be able to have for a trainer here is their favorite mart. This is a string in the collection that we have or in the reference that we have in our class. This is a literal class reference to Pokemart. But in our SQL database, we're not able to refer to another table in its entirety. Instead, we're going to refer to a specific property on that table. And so for my favorite mart, it's going to be the name of the mart itself. So this will be varchar 255. And I'm going to add to this. This is referring to the name column. I'm going to pick a different color for this. I'm going to call this is a foreign key. This is a foreign key on Pokemart name. I'm going to ask you to just blindly accept the words foreign key. Foreign key here for us means I'm referring to some other column on this other table. The foreign part of foreign key is it's not in my table. It's in some other table. Key is this is a unique identifier for all of the things that are in this table. So my trainer table now consists of two columns. One is the name of the trainer, and the other is the name of the favorite mart that they have. The last table that we're going to have in this is for the Pokemon itself. This is another rectangular structure. I'm going to have columns in my table. My Pokemon is going to have a nickname. The type of this will also be varchar. It's a string. our Pokemon have HP. These are integers. So in TypeScript and JavaScript, we're using number. In Java, we're using int or double or float or some other kind of type to represent numeric values. In SQL, we have floating point numbers, but int is the type integer here. And the other thing that we're going to have on our Pokemon in this table is who are they owned by? So the trainer. This, just like favorite mart up here, is going to be the type of the key that we have for our trainer, the name of our trainer. So this is going to be varchar 255. I'm going to add this reference. I'm going to choose a different color for the label that I write on this. But here, we're referring to the name of the trainer. So I'm going to use this label again here, foreign key. Trainer name. I'm adding a reference from the Pokemon table back to the trainer. There are a couple of things that were extra that we added to our class diagram, like the name must be unique on the Pokemart. So I'm going to add that. This must be unique. We said that the name of our trainer must be unique and that this is nullable. So you're allowed to have a favorite mart, but you're not required to have a favorite mart. And we said that of Pokemon, this must be unique. The nickname must be unique. The trainer is not nullable. You must have a trainer. You cannot be in the database as a Pokemon without actually being owned by a corresponding trainer. The value for integer for our hit points doesn't need to be unique. It doesn't really have any other kind of properties. It can't be null, so I don't want to say that this is a nullable value. So when I'm thinking about my table structure, this is what's in my head. I want to be able to insert data into this. And so when I'm thinking about inserting data here, I'm thinking about rows in the database. I'm going to have a mart that I'm going to add where the name of that mart is going to be the Mount Moon Mart. This table now has one row in it. It corresponds to an instance of the Pokemart class. I can add another row to this. Now my table has two rows, and each one of these rows corresponds to one instance of that type in my system. I also want to insert values into trainer. So I'm going to add myself. And at least to begin with, I don't have a favorite mart. This is acceptable. It's okay for me to not have a favorite mart. I now have one row in the trainer table. This corresponds to one instance of trainer in my system. I'm going to add another trainer here, Walter. His favorite city mart is the Mount Moon Mart. When I pull Walter out of this as an instance of the trainer type, what I would want to be able to now say is that Walter has an instance of or a reference to the instance of Pokemart that is the Mount Moonmart here. Yeah. We do have something back to trainer in the form of Pokemon here. So this final column here for our Pokemon is the foreign key back to the trainer's name. The array in the Pokemart we don't really have directly. Instead, we have the favorite mart from the trainer itself. So to that point, we don't have arrays here anymore. I'm going to add some Pokemon here. I'm going to add Bulby. It has HP of 10, and it has a trainer of Franklin. I'm going to add Charmy. It has an HP of 5, and it has a trainer of Franklin. I'm going to add one more. My daughter was playing this last night, and she named her Charmander Fire Moon. So we'll put that here, and I'll just say that I own it. I'm sorry, daughter, I'm stealing your Pokemon for a class example today. We do not have an array of Pokemon in Trainer. Instead, I have many rows in my table that all have the same trainer. We've inverted the relationship that we have here. If I wanted to express this idea by making changes to the trainer table, I'd now have to have effectively a column for every Pokemon that I want to have here. And I just cannot structure my tables that way. I'm not able to have an arbitrary length on the columns that we've got for this. So we're inverting our relationship, and we're duplicating this lots of information. I'm putting Franklin in here constantly, but that's okay. That's okay. That's kind of a necessity for us to be able to structure the things that we want to structure this way. Yeah.
So the back reference that we're having in here, the Pokemon referencing to a trainer, we're only enforce that in the database and not in the actual text.
So the back references we're only going to be able to enforce in the database, yes, because it will be implicitly added as the collection when we're kind of pulling this back out of the database. When I want to get a trainer out of the database, my job will partly be to go to the Pokemon table and find out who has, which Pokemon does this trainer have. So for which rows is the value of that thing, Franklin? Yeah. Yeah. It will always, yeah, if we want to have a foreign key on something, it has to be for something unique. If I try to add a foreign key on something that's not unique, the database will forbid me from making that table in the first place.
So yeah, in table Pokemon column trainer, do we actually store like string value of Franklin or reference to the another table?
For us, for right now, we'll actually store the string that's called Franklin. But when we're inserting these rows into the database, our database is going to be checking, does a row in the trainer table exist with that string as its value? It will actually be enforcing that for us. So with a structure that I've got right now, I'm not going to be able to add a row that looks like this. I'm going to put a big red X here. This will not be allowed. This will not be allowed because there is no trainer in the trainers table. There's no row in the trainers table that has a value for its name of Gary. Right now, that will not be allowed to happen. I cannot add that row to the database.
So it is entirely SQL that is responsible for manageable constraints and the kinds of rules that we added to our data.
It's going to be the responsibility of our relational database to do this stuff for us, yeah.
Later we will accept like errors from it.
Later, we're going to have errors that are being raised by our relational database for things like mainly about the uniqueness constraints on things. So I don't really want to enforce this with TypeScript. I don't want to keep track of every object that has ever been created of this type so that I can enforce uniqueness in TypeScript. I'm going to let my database do that job for me. It can keep track of everything, and it can be the one that enforces the uniqueness of those values. Yeah.
So we don't have arrays anymore in this diagram here, but like we're still sure that we've comprehensively covered like that we're still going to have an array of Pokemon for a trainer
Yeah.
in our model.
So we don't have arrays anymore. You're right. And the way that we've done that is we've taken arrays here on a trainer and we've turned it on its side by putting them into the Pokemon class. So the relationship that we had between a trainer and Pokemon was that a trainer has many Pokemon, but the opposite side of that was that a Pokemon has one trainer. And because a Pokemon has one trainer, we can express that here. And now we're able to say that the collection of Pokemon that is owned by the trainer named Franklin is all of the rows in this table that have that trainer name on them. Yeah. So this is a one-to-many relationship, yes. We have not done many-to-many here. Many-to-many would be that I would have to add an additional table that represents all relationships, but that would be its only job, is representing the relationships between things. We're going to omit that for now, just to get the basic idea of what we're thinking about started. Yeah. Any other questions about this like mental image of what this looks like? Okay. All right. Okay. I will share this diagram with you after class. I want to go over here. And what I want to start doing with writing some code is I want to write some SQL that's going to do a bunch of stuff. I want to be able to make tables that have these uniqueness constraints and have references to other tables. So I want to take the structure that we've got there, and I want to be able to encode that in SQL. I want to be able to add data to my database. I want to insert rows, and I want to be able to see what happens when we have constraint violations. So what happens when I try to insert a duplicate value? What happens when I try to insert something that doesn't have the corresponding key in the other table? So what happens in the case of I'm adding Pikachu here and Gary? What will we actually see as a result of that? I want to be able to get data back from the database. I want to pull data out. I want to ask questions about the data. I want to describe the data that I want to get, and the database will give that to us. I want to be able to update records, and I want to be able to delete records from tables, ultimately leading to the idea of I want to be able to cascade on things. I'm not going to step through these slides, but I have included these slides here as a reference for you, so you don't have to like hastily type down all the commands that I'm doing. These are the commands effectively that we're going to be running in class. I've tried to put comments on here describing what each of these things does. I want to step through this verbally. If you want to follow along with me, I very much welcome you to, but I don't want to have to like feverishly typing the stuff that I'm typing to follow along. So all of these slides are here for your reference if you want to be able to take a look at that after class. I'm going to be using this REPL. This is from something called pglite. This is what I showed you last week. This is linked to on the course webpage under today's lecture notes. The pglite is the software that we're going to be using internally for our projects going forward, but it gives us this nice interface that we can just run SQL commands, so we don't have to worry about integrating things with our code for now. So the very first thing that I want to do before we can do anything is I want to start adding some data to, I want to be able to create these tables for my databases. So the syntax that we're using here, again, is create table. This is what we had this hazy idea of at the end of last class. Want to create a table. I want to give that table a name. And I have to be able to describe the data that's going to be put into that table. So I have to be able to describe the columns that are in that table. So within the parenthesis, I'm going to say things like each Pokemart has a name. Its type is varchar 255. This is going to be not nullable. I'm forbidding null values to be inserted here. We must have a value for this. And the values that we put into this must be unique. For Pokemart, there are no other columns. There are no other constraints. I just have that one column that represents the name of the Pokemart that I've got here. Now that we have the Pokemart, I want to make the trainer. So the name of our table is trainer. Our trainers have two properties. They have a name themselves. It's a string, varchar 255. It is not allowed to be null. You must have a name. You cannot have a trainer without a name. You must have a name. And the name that you provide must be unique across all instances of this class, as enforced by the database. I want you to also be able to have a favorite mart. And this is going to be of type string, varchar 255. And I want this to refer ultimately to this value. I'm looking back to that other table. This is allowed to be null. You're not required to have this. And it doesn't have to be unique. Many trainers should be able to favorite the same mart. There's no restriction on me having multiple trainers that have that same favorite mart. But I do want to say that I have this idea of a foreign key on some other table, foreign. There's a key, a unique value that I want to refer to with this table's keys or this table's columns. The column that I want to have this reference on is called favorite mart. And it references the Pokemart table. And the specific column that it references is name. So I've got a name for this table. The column is of type string. It's not allowed to be null, and there can't be duplicates. I've got a favorite mart. It's a string. I can have null. It's not required to be there. I can have duplicates. I want many trainers to be able to favorite the same mart, but the mart must exist. You can't favorite some mart that doesn't exist. You have to choose something for this if you choose a value that exists in that other table here. The last one that I want to make here is for Pokemon itself. So I'm going to create table, Pokemon. I need to name the columns that are in this table. My Pokemon have a nickname. They are of type string. They cannot be null. You must have a name. And we're going to enforce, this is a little arbitrary on our part, we're going to enforce that you can't have duplicate names. Everybody has to choose their own distinct name for every single Pokemon that's in this system. Pokemon have hit points of type integer. We're going to say that this is not null. You can't put null. Integers in SQL are nullable. That means that it doesn't have a value. It's not 0. It's nullable. You can put null here. I want to make sure that you actually put a value here, so I'm going to say that this is not null. But it doesn't have to be unique. And I want to have a trainer. This is of type string, varchar 255. It cannot be null. You must have a trainer to be in this system, but it doesn't have to be unique. I want Franklin to own lots of Pokemon, not just one. My trainer refers to another table, so foreign key. It's referring to another part of another table. The foreign key that I have on the Pokemon table is trainer. It references the trainer table. And the property that it references on the trainer table is that unique key name. We've got our 3 tables now. So our mental model is, I've got table 1, table 2, table 3. There's like gray arrows that are pointing around. There's these foreign key references. I've got 3 distinct tables in this system. Now that we've got those tables, I want to start putting stuff into the tables. I'm going to start with some marts. I want to insert into Pokemart. When I insert, I'm inserting into a specific table. And then I have to describe the values that I'm inserting. I have to describe what columns I want to insert things into. This is not strictly necessary, but I like to do this, and so I'm going to ask that you also do it. This is just like my opinion. You can do this differently if you want to, but I will always be structuring it this way because it's clearest to me like this. I want to insert into Pokemart in the column name certain values, and the values that I want to insert here are, I'm using single quotes on purpose. In SQL, we need to use single quotes, at least in the tool that we're using for strings. We just must use those. So I want to insert into my Pokemart Mount Moon Mart. I want to add another one, Viridian City. And I'm going to do this again. I'm going to try to reinsert this same value. Remember that the name of our marts is unique. It must be unique. So if I try to do this again, we get this error that comes up. Duplicate key value violates unique constraint on Pokemart name key. So because I've tried to reinsert this Pokemart with the same name value, it's forbidding me from doing that. This must be unique across all instances. And so instances here now are rows. Each row must have a distinct value in this setup that I've got. Now I want to insert into trainer. I'm going to add trainer here of me. I'm able to do that. My trainer table has two columns. One of them is name and the other one is favorite mart. Here I'm inserting only a value for my name. When we created the table for our Pokemart, we said that, for our trainer, sorry, we said that the favorite mart is nullable. It's allowed to be null. I'm going to insert another row here. I'm going to insert a row that refers to a trainer with the name of Walter. And I'm going to say that Walter's favorite mart is, I'm struggling to remember now because it's been a very long time since I've done this, but there's a city that you can go to where you can get a Porygon from like a slot machine area. Does anyone remember the name of that city? Nobody. Nobody else is like a giant Pokemon nerd here, I guess. That's fine. That's true. I still respect all of you the same amount. Now I'm just completely lost. What are some other cities in Pokemon? Cerulean? Good enough. Cerulean Mart. Okay. Thumbs up. Thumbs down, very quick. You've got like 5 seconds to decide. Will this actually work? Thumbs up, yes. Thumbs down, no. Good, excellent. No, this will not work. There is no row in the Pokemart table that has that value. We are forbidden from doing this right now. So instead, we'll say that Walter's favorite mart is Mount Moon Mart. This will succeed because there is actually a row in that table that has that value. I want to get some data back out of this. And so I'm going to use a new statement here that is select. Select is, I want to describe the data that I want to get back from the tables. I'm going to say select. The thing that we provide to select is the name of the columns that we want to get back, or I want to get everything back. I want all columns. We'll start with that one. I will say select star. Select star says, give me all of the columns from a specific table. I'm going to say trainer here. Select all the columns from trainer. We've got 2 rows. We've got one for Franklin. There is no favorite mart here. And we've got one for Walter, where Walter has a favorite mart that is set to Mount Moon Mart here. I'm going to say that I want to add a favorite mart for Franklin. And so we're going to make a change to an existing row in the table. The command for that is update. The thing that we need to tell SQL that we want to update is the name of the table, the name of the table that I want to make changes to is trainer. We have to say set. This is me now describing the changes that I want to make to rows in that table. And I'm going to say favorite mart. Okay. I'm going to pause here for 5 seconds. I want you to think about what this statement looks like it's saying. Okay. I'm going to hit enter. That's not exactly what I was hoping to accomplish. When I'm doing this update, I have to really specify which row I want to actually update. So I'm going to bring back this command, update set favorite mart. I'm going to change this back to Mount Moon. And we have to add one more thing. We have to add this thing called a where clause. This is, if you squint at it, conditional statements. These are going to be Boolean statements about the data that we have in the table. So I want to update the trainer table. I want to set the favorite mart to be the Mount Moon Mart. And I only want to do that where the name of the trainer is equal to Walter. I only want to set it for that one specific row. I'm going to hit enter here. And I'm going to select from trainer again. And now we've changed just that one row to be the Mount Moon Mart. We've updated just that one row here. I'm going to add a Pokemon. Pokemon have nicknames, HP, and trainers. We have to specify all properties here. All of them are effectively marked as not null. Quick decision, yes, no. Is this going to work? Thumbs up, yes. Thumbs down, no. Good. This is going to work just fine because we have that foreign key. If I try to insert this again, very quick thumbs up, thumbs down. Is that going to work? No. There is no key in the table trainer for Gary. I'm going to run one last query here. And the one last query that I want to run is delete. I'm going to say this, delete from trainer. Delete from trainer says, delete from trainer. Delete from trainer actually says delete all rows in the table trainer. Okay, this did not work because this table Pokemon has a foreign key on trainer. And if I were to delete that reference, so if I select star from Pokemon here, whoops. If If I select star from Pokemon here, Bulby has a reference to the trainer table, and it's referring to that key that has value Franklin. If I tried to delete from trainer where name is equal to Franklin, then this reference will be violated. There is no foreign key with that value anymore. And so our database will forbid us from doing that. If I want to do that, I'm going to need to make some changes to the structure of my table, and we will have to take a look at that next week. At this point, though, you should be able to model these relationships. So take your existing class diagrams, annotate them with some extra information to be able to start thinking about the idea of putting them into a data model. And you should now be able to start writing queries and at least reasoning about whether or not queries will succeed based upon the constraints that are in the tables that we have as they are right now. That's it for today. I will see you all on Thursday. Bye, everybody.